Good afternoon. So today we're going to talk about cloud limits. And limits, when we talk about cloud, it's not something that is going to pop into our head immediately. But as we start to scale our projects, we're quickly going to realize that it is an important aspect to consider. So what kind of limits do we deal with when we talk about scalable solutions? And how can we effectively overcome them when we engineer those solutions using infrastructure as code tools? Today we're going to take a look at those questions. A little bit about myself. First and foremost, I'm an engineer, so I like challenges. I've been doing software engineering, data engineering, relatively recently cloud engineering. I'm also founder. I'm running a boutique consultancy across the bridge in Copenhagen. I consider myself challenge-driven, so the first two boxes is where I find my daily challenges, both technical and non-technical. And the recent years I spent building cloud-based data platform. This is what I specialize in over the recent years. So just to take a moment and align on why we would use cloud computing in general, we have a bunch of advantages. First of all, the data centers are located across the world, so we have a very easy way to create our systems in different regions if there is the need for that, to replicate them if users are located globally. Those systems are also considered very secure. We have other advantages like operations, maintenance, cost optimization, and recently sustainability is becoming a big topic because the data centers are running on carbon neutral. There are some promises to move towards that direction. And scalability is often mentioned as one of the reasons to use cloud computing. But then, this topic, we also need to introduce the domain of cloud engineering, which is relatively new. It's dealing with how we use cloud computing systems in an automated way, so how we design and implement them in automated ways, so using tools such as infrastructure as code. And also scalability is mentioned here, and that's, again, our focus for today. So to base the talk, since we're going to talk about cloud limits, we have different categories of those limits. And some of those categories we're not going to touch today. This is the legal aspect where many different organizations and sectors still have a lot of regulations, so they are not so keen to transition to those systems for various reasons. There is also knowledge gap. Often those are new technologies, a lot of services are being offered, and the knowledge is something that is not so easy to catch up. There is an aspect of cost. It doesn't make sense for all to move into the cloud environments because the cost doesn't always justify it. And then we have a bunch of limits that we're going to touch on the talk today. So we're going to focus on service quotas, API throttling, and then we're going to touch a bit about resource constraints, and in particular, infrastructure as code tools. And when we talk about infrastructure as code tools, they have their own set of limits. In particular, when you define your infrastructure as in code, you will write a piece of software and you think, okay, this should work. But when you start deploying it, it might turn out that it works in your account A, doesn't work in your account B. You don't have a breakpoint to put once you have written it. So it's actually quite tricky to ensure that it's correct. So the testing aspect is not so easy. Of course, there are tests, but it's not very smooth compared to traditional software. Not all services will get infrastructure as code support right away. especially the ones that are introduced, the new services, they have to catch up. Operations, that is when we talk about scaling, we often have problems with operations. And then the two things we're going to highlight today, developer experience and complexity. So when we talk about infrastructure as code, we have a bunch of options to choose, a lot of tools. That's just a glimpse here. We had a talk today from Thomas about Pulumi. That's a very nice tool. But for this talk, we want to go a bit deeper into specific technology. So we're going to focus on CloudFormation and Cloud Development Kit. So we're going to go cloud native on AWS. And just to give the general overview of infrastructure as code for those of you who maybe didn't use it yet, the general idea is that we have our Git repository where we store our code. In the example here of AWS CloudFormation, we have some JSON YAML templates, and we use our DevOps platforms such as GitHub or GitLab to then automatically deploy our code into account. And then with this particular case, we have CloudFormation, which is a service on AWS that's going to be provisioning our resources. Now, to add to the complexity and general also background of cloud computing systems, it's nice to mention that they are accelerating. So with AWS, they have been the first public cloud offering with the first service started around 2004, and the number of services and what they can offer is just accelerating every year. They are becoming better, new ones are appearing, so there is the acceleration aspect of it. And there is also a complexity aspect with more than 200 services available today. So when we talk about cloud and engineering and architecture, the amount of things we have to know and also the number of ways we can solve same problem is high. So we have to somehow manage that complexity, understand generally what the services are doing. And to help us with this, in the context of AWS, we have a tool to help us with this complexity. It's called Well-Architected Framework, where we can, using this chart here, it's actually on the website, we can go through different kind of advices to help us maneuver our architecture, because there is no perfect architecture. We always try to balance with respect to the pillars that we see here. So for example, our architecture could be very performance efficient, but it may be not cost optimized or not sustainable. So we always try to balance, and that's important when we talk about scale. This is important because this is where we are actually architecting for scalable solutions, also arriving at an architecture that is balanced for us. And also to constrict and make a concrete example for this talk, we're going to touch the domain of data analytics. So we pick a few services from those 200 services that we're going to touch today. And we're going to do data ingestion. So we're going to ingest data from Salesforce, relational database, stream, and APIs using Amazon AppFlow, which is a service that is no-code solution. You just point it to your SaaS platform, and it's ingesting data to clouds, here to the object store S3, which is AWS offering. Then we have Glue, which is a serverless Spark service for AWS, and we can do smaller ingestions with Lambda. And with this domain, let's introduce the example challenge that we have. So the challenge is to ingest the data from around 3,400 objects spread out across those 5 systems. So we have 3 Salesforce instances, we have Adobe Analytics and Google Ads, and we want to create an automated infrastructure as code solution for this problem. So you might be thinking, okay, we have 3,400 objects to ingest. This is going to be easy because the cloud systems are very capable. But then that's where we start the talk about the limits. So we're going to use Amazon Upflow for this ingestion, which is a service that we pointed to SaaS platform and ingest into the cloud. And then some of the limits I picked for this talk are as follows. We can create 1,000 flows per one account. We can run 1,000 flows in parallel. Then at a given point in time, Upflow API allows 30 flows to be created in parallel. And there is a general guidance to ingest up to 100 gigabytes of data. And as mentioned, we're going to use CloudFormation for this talk. And some of the limits also that we have to, as cloud engineers, respect are 500 resources per stack, 2,000 stacks that we can create in a given account, 3,500 operations in parallel, and our templates, JSON YAML templates, can be 1 megabyte in size. Now, we can solve some of those limits by asking AWS just to increase them. This is what we call service quotas, and some of them are adjustable. So the 1,000 flows that we can create per account, it's an example of an adjustable limit. So we just say, please increase this limit. In our case, it could be 3,500, could be 5,000, depending how much we think we're going to scale. Similarly, if we want to run in parallel those flows, we can increase the limit on the number of concurrent runs. And likewise, for CloudFormation, we can, if we want, and we're just going to go into the concept of stacks very soon, ask AWS to increase the 2,000 limit and 3,500 operations, update operations, if there is a need for us. But as you see, not all of those limits can be adjusted like this. So to go and engineer a solution, let's just look at the basic CloudFormation concepts. And those concepts, of course, are going to be different across our different tools that we use, different infrastructure as code tools. But for CloudFormation, the concepts are, as mentioned, we write the templates in JSON or YAML. And those templates put cloud resources in what we call stacks. So a stack can contain resources directly, such as virtual private cloud and IAM role in stack 1. Or they can, we have a concept of nested stacks. So in stack 2, we have stack 2.1, then contains resources of its own. What is important to mention is that we can reference stacks, reference resources that are outside of a given stack. So we see that the function as a service offering of AWS Lambda is referencing some resources in stack 1, but is located in stack 2. That introduces dependencies between those stacks. So when we deploy with CloudFormation our solution, stack 1 will be deployed first, and then stack 2 will be deployed afterwards. What is also important to mention in the context of limits is that the nested stack count as one resource. Remember that we mentioned that we have 500 limits on the number of resources in a stack. A nested stack is one limit, so one resource. So stack 2 effectively has 2 resources. It has Lambda function, so that's one resource, and nested stack 2.1. And this is important because then we have to architect our solution. So remember, we have this 3,500 objects we want to ingest. And we could say that, OK, we want to introduce a CloudFormation stack containing 700 upflow flows. Every flow is ingesting one object from our Salesforce platform. And we could do it like this. But that approach will be crossing our limits that are marked here, both of them. First of all, we put more than 500 resources in the stack, which is, we cannot cross this limit. It's a hard limit. And we have the API limit of on Upflow that we can create 30 flows in parallel. And if we do a stack design like this, assuming we could put 700 resources, what CloudFormation will do is that it will try to provision 700 resources in parallel. So the 30 API limit will be crossed. So what we can do to overcome this limit of 30 resources, the API limit of upflow, is that we can introduce the concept of a stack unit. And a stack unit then consists of 30 flows. So when we provision this stack, we will send up to 30 API calls to upflow service. But we still didn't solve the original problem, because we need to ingest these thousands of objects. So in order to do that, we then model our stacks to be composed of the stack units that we just introduced. Yeah? So if we were to create 700 flows, we would model this by having 24 stack units contained in a stack. In this way, you can remember that every stack unit is going to be one resource. So we have effectively 24 resources in this stack, but we are crossing 30 limit on upflow again. Do you know why we're crossing this? Anyone can guess based on what we talked already? All created in the same time. So CloudFormation will try to provision all 24 stack units in the same time. We effectively cross the API limit. Thanks for the answer. So what we can do to fix this is introduce the concept of dependencies, and we can do this implicitly. What we showed in the beginning, that we can resources can reference resources from other stacks. That is an implicit example of dependency. Here, we can actually in the code say that stack unit 2 depends on stack unit 1 and so on. And what that will cause is that stack unit 2 will only start being provisioned when stack unit 1 is provisioned. And we will take longer time, but we will, after this is provisioned in the account, create 700 objects in this stack. So we have an example of scalable solution here, using the concepts of CloudFormation, the basic concepts of CloudFormation that we defined. And with this example challenge, then we can model all those 5 systems containing hundreds of objects with this CloudFormation stacks consisting of stack units. We have all the non-adjustable limits checked, so we didn't cross any of them. Can any of you tell me how many stacks we have now defined with this solution? Five, yes, very good. So all the stack units that are inside are not considered as top-level stacks. So we have 5 stacks that are ingesting 3,500 objects. We have a limit of 2,000, so we can really create many more. We can ingest many more objects with this approach, and none of those limits will be breached. So this is an example of a solution that we utilizes the concepts of our tool, and it's really prepared for the future. We can scale easily with this approach, but we can then take it a step forward to productionalize this approach, and we can introduce the concept of a configuration file. And with this configuration file, we're going to say how we configure each of those objects from the SaaS platforms. And we can then, as we operate the platform, we can add and remove objects. And using a lookup table, which is a key value store, a DynamoDB table in AWS, we can then, with the help of it, write our infrastructure code in a way that we're going to be, once we remove something from the configuration file, we're going to know that there is a spot in this particular stack unit that we can then, if we add another object, we can fill it in. So we will not be creating these stack units that have gaps, and we can further productionalize this. And that's actually a solution that is running in production. and it's scaling very nicely. The team that operates then the ingestion of the data can, using the configuration file, control everything. Remove, add. It could be something very tricky with CloudFormation. Before this solution was implemented, there were a lot of operation errors, and this is now running for more than a year without any major operation disruptions. So an example of something that can scale in production. But then we have some special cases. With Upflow, what we typically do is we say we map all the fields that are in the source system for a given object to be ingested. But what we sometimes have to do in practice is restrict the different columns that we ingest from those objects for different reasons. Could be PII data, could be that we don't need all of those columns, or we want to remove some of them. And then when that happens, the CloudFormation template explodes. So what we can then breach is the limit of 1 megabyte size of the CloudFormation stack. And when this happens, what we can do is we can put those kind of special flows in their own stacks, because there's not going to be a lot of them. But we will then be quite sure that because each stack has its own template, we can be quite sure that we will not be breaching this limit, which is a hard limit. And we also have an important category to mention in the domain of data analytics, because we're ingesting sometimes large amounts of data. We have this limit of 100 gigabytes with Upflow, and that's just basically current state of affair with that service. If something changes, of course, we can then utilize it, but with a limit like this, a recommendation like this, we have to adjust to that. Yeah? So one way to adjust is to switch the service. And a good switch in AWS land is the Glue service, which contains the serverless Spark cluster, which can handle large amounts of data. So that's something we can utilize. We can switch when needed to have a better bandwidth to ingest the data. But then we can also talk about infrastructure as code tools from developer perspective. And as mentioned, going cloud native with AWS, we have an option of using CDK and CloudFormation. CloudFormation is a service that is provisioning the resources. But then there is also Cloud Development Kit. And what Cloud Development Kit is the ability to write a wrapper around CloudFormation use using a familiar programming language. So you can use TypeScript, you can use Python, you can use Java. And all the previous concepts that we introduced of stacks, references, dependencies are present. It's just that we have a wrapper now using Python in this example, where the complexity aspect is different, because we can use software development best practices. We can do unit code, unit testing. And the example here is one-to-one translation. So this amount of code on the left generates our stacks. We can reduce the duplication with CloudFormation templates. We have to duplicate everything. With the Python code, we don't have to do this. So CDK is taking away this complexity aspect. And then we can talk about developer experience, because we also have a concept of constructs, where when we mature our infrastructure, we can define certain patterns and then program them as constructs. So we can put resources that we know will solve certain use case for us. For example, in this case, we are ingesting data from relational database. We know a certain combination of resources is going to solve that problem for us. So we introduce a construct and then instantiate it 3 times in this case for 3 different relational databases. And this, as a developer, is unlocking a potential for easier use of our tool power, because with CloudFormation, again, we would have to write each of those resources on its own as separate lines of code. So developer experience, very important to keep in mind. So with this, talking about limits, I think it's important to remember and consider service quotas. When we think about implementing a really scalable solution that we know we're going to maintain for years, it's worth to invest a bit of time and read about the service quotas and what categories there are. Because some of them we can adjust, some of them we have to work around. And to work around, we have to utilize our tools. So whatever tool you choose, if it's Terraform, if it's Pulumi, if you choose some cloud-native solutions, spend some time, study the concepts, because those concepts, they can help you overcome the limits. By using them in smart way, you will be able to overcome the limits and define a solution that can really support your scale. Adjust if needed, so don't get stuck on using specific services, because it's very easy to blend services, especially with the concepts such as the constructs for CDK. It's very easy to do inheritance, to define multiple constructs and support this idea of blending services, how we use them. And consider developer experience, because in the end of the day, developers, when they have powerful tools, they will create powerful solutions. So this is something that is not to be missed out when we select the tool. And when we bring them together, all of those 4 points, I believe we can arrive at solutions that can scale. So I hope I gave you some inspiration how to build those solutions yourselves. Thanks a lot. Any questions at this point? Then thanks.